So similar to abstract classes, of course, is the concept of interfaces. And let's go ahead and create an interface, and then I'll mention some of the minor differences with regard to abstract classes. So I'll go to Kotlin and I'll say, what do I want to here? Let's create, for example, a customer repository. Let's say customer repository, and we're going to select an interface. So this interface is basically the contract, which is what interface is very often referred to as, a contract that has to kind of like abide the person that is implementing it, as well as the person that is consuming it. So I'm going to say that this contract has a function which is, for example, get by ID, that given an ID of type integer, it's going to return a customer, for instance. And now let me go ahead and implement this interface. So I could just write class, customer, repo, and we're going to call this, for example, a SQL customer repo, SQL customer repository, and it's going to implement the customer repository. And we can see that the IDE tells us, oh, you need to implement this interface, so I'm going to select the members and I'm going to implement that interface. Now, going back to this interface, let's go ahead and add something else. We're going to do, for example, a fun, and we're going to say store, and it's going to take an object which is of type customer, and it's going to implement some code that will store. Now notice here, the code actually, what it implements is not important. What's important here is that there's a body, okay? And this is different to some interfaces in some other programming languages. Now, in C#, for instance, an interface cannot have any kind of implementation. If you want to do something like that, you would use what's called an abstract class, which we just previously saw, where you can have methods that have default implementations, and then those that are abstract that the inherited classes need to define the implementations for. In Kotlin, very similar, well, not similar to Java 8, interfaces can have default implementations. And initially in Kotlin, interfaces were called traits, similar to Scala. But then when Java 8 came up with the ability to also have interfaces with default methods, default implementations, we decided to rename it also to interface. But that then begs a question, like we just saw that an abstract class allows us to, have default implementations, have abstract methods. An interface allows us to have default implementations and abstract and not implemented functions. So what's the difference? One key difference is that you cannot maintain state in an interface. So you can have an abstract property, but you cannot implement any kind of state. You cannot maintain state, whereas with an abstract class you can. I cannot have a class that inherits from two base classes, whereas I can have a class that inherits from a single base class and then implements multiple interfaces. So that's another important, very important difference, because as I said, Kotlin, like many other languages such as Java and C#, have a single inheritance model. As I just mentioned, interfaces cannot maintain state, but they can have properties, and these properties can be abstract. So let's go ahead and declare a property which is called isEmpty. And I'm going to just say that isEmpty is of type Boolean, and you can see that that's absolutely fine. But if I try and do equals true, look what happens. It says, well, property initializers are not allowed in interfaces, obviously because they can't maintain state. However, what is possible is to provide getters and setters. So I could actually do get true, and what that does is say that isEmpty is always true. Now, that really is of very little value, right? I mean, in all practical cases, you wouldn't do something like that. But you can have custom getters and setters. What you cannot do is maintain state, which is different. In interfaces, obviously, you can override implementations, as we've seen, because you have to actually implement those implementations. And much the same way, you can override for properties as well. So I can do val isEmpty and override that and say that this is always false in the actual implementation. So what we're doing here is that notice that the property actually has a so-called default implementation, and we're overriding it. So that begs the question of what about member functions that also have default implementations? Can we override those as well? And effectively we can. Let me just go ahead and return a customer here so that we get rid of the compiler error. And you can see that I can override the store function. So by default, it's going to call super.store. So it's going to call the base implementation of this and do whatever that default implementation is going to do. If not, I don't want that. I can just remove it and then do my own custom implementation. So although in interfaces we have the ability to provide default implementations, it doesn't restrict us from overriding these in classes that implement those interfaces. So let's look at a particular situation. Let me create an interface. I'm going to call it interface1. And it's going to have a function called fun_a that's going to have an implementation, default implementation called fun_a from interface1. And let me just duplicate this. And let's call this interface2. And it's going to be also called fun_n, and it's going to be interface2. All right. Now let's go ahead and minimize this. We don't want to see that. And let's create a class, which is interface1, or let's call it class 1 and 2, which, as you might guess from the name, is going to actually implement interface 1 and interface 2. So I'm going to implement members. Now, you can see that I'm only implementing a single member because it's just a single member. It's the same name. Okay, that's fine. We're going to actually delete this line, and if we provide our own implementation, it's our own. And if we run this in the main, we can do, for instance, val our class equals class 1 and 2. And let's go ahead and call fun_a, and let's see what happens. It should execute our own. Yes, because we've provided a default implementation. Great. Now, if you remember from before, when we had this store, we had the ability to call superstore, right? Because we're saying, okay, you know, just delegate that to the base implementation. I don't want to do anything special. I don't know why I've overridden it. Or maybe I want to override, do some logging here, and then let the rest be handled by the default implementation. What about the case where we have this situation where we have two interfaces? Which one do we call? Because we can't actually come here and say, you know what, let's call super fun_a. Which one? It doesn't know. Should it call this one or should it call this one? Now, if I remove this implementation, it's fine. It knows which one to call because there's only one implementation, so there's no ambiguity. But in this situation, there is. And we can resolve this by putting in the greater than lower and the actual interface that we want to call, the actual function of the corresponding interface that we want to call. So if I want to call interface 2, now I'm calling interface 2. So if we run this again, we should have fun_a from interface 2. Okay, and we can see that that is correct. So when you are implementing multiple interfaces and these have default implementations for methods that are actually called the same, you can actually refer to them by using super and the same notation that we're going to see soon for generics and then the actual function name.